Hello, everyone, and welcome you all to our today's discussion on the second unit of Advanced Probability and Statistics. Today we'll be discussing Unit 2, which consists of expectation and several laws of large numbers. However, before beginning with Unit 2, I'll just make you go through the Unit 1 real quick. In Unit 1, we studied about random variables and their types, the different kinds of distributions, PMF, PDF, and CDF. So PMF was for discrete variables, density was for continuous variables, and CDF was for both continuous and discrete variables. Up next, we had joint and marginal distributions, where joint distributions showed us the relation between two variables, and the marginal distribution was the summation or integration of one variable with respect to the other variable. Independence refers to like knowing that one variable does not affect the other. Then we had conditional probability and Bayes rule. Then we had Bayes theorem. Up next, we had expectation, variance, and covariance, where expectation and variance we'll be studying in this unit in much more detail than we did in Unit 1. Then we had correlation as well. So Pearson's rank formula. Then functions of random variables. Then joint probability distributions, that is continuous joint distributions. Then marginal probabilities of both x and y. And after that, applied probability, strategy, and sample spaces. And finally, we also had, just a moment, correlation, okay? That is covariance by standard deviation of x into standard deviation of y. So that was all we covered in Unit 1. Okay, then we had this final formula sheet, which you can take a printout or you can write in some sheet, which will help you in revising the entire Unit 1. Now let's begin with our today's topic, that is expectation, moments, and law of large number. Friends, I would request you that as we keep on proceeding, you all please, be there with a notebook or a sheet and keep practicing the sums simultaneously, because this chapter is a pretty tricky one with all its laws and formulae. Okay, so without any further delay, let's begin with transformation of random variable. So here I have included a very simple example. When you were a child, your set of actions was limited: playing, eating, sleeping, and maybe watching cartoons. That was your range of activities. As you grew older, say into your teenage years, you could do more. That is, travel alone, handle money, attend events. That is, your range expanded. Okay. आप जब छोटे बच्चे थे तब आपकी सेट ऑफ एक्शंस क्या थी, कम थी. ओके, इट वाज जस्ट लाइक स्लीप, ईट, देन गो टू पार्क, प्ले विथ फ्रेंड्स एटसेट्रा, राइट? बट अभी जैसे जैसे आप इवॉल्व, आप ट्रांसफॉर्म हो रहे हो इनटू योर अर्ली एडल्टहुड, योर रेंज ऑफ एक्टिविटीज इज changing. Okay, now what you do, you go to university, then you take up some extracurricular hobbies, you handle and spend money, you attend events, etc. Right? So in math, something similar happens when we transform a variable. So suppose हम एक random variable x दिया हुआ है. Now from unit 1 we know how to conduct certain operations on one random variable. But what if हम x के रेस्पेक्ट में एक और रैंडम वेरिएबल इंट्रोड्यूस करें? उसकी प्रॉपर्टीज हम कैसे डिनोट करेंगे? जैसे if energy level y equal to root x or learning outcome y equal to 2x plus 5. So in this case, y is said to be a transformation of random variable x. ओके, अब x के ऐसे क्वेश्चंस में हम सबसे पहले क्या करना है, x की एक रेंज आपको दी रहेगी. जैसे in this example बचपन में आपकी range of activities, okay. But as you grow older, what happened? Your range of activities change. Similarly, when y takes up a new value of function x, so x ka range will not be equal to y ka range. Instead, y will have a new set of domain, codomain and range. So for 1D transformations, we have a function y equals to g of x, and we want to find the distribution PDF or PMF of y, okay? So, case A, discrete random variables. If x is discrete and we know p of x equal to xi, so what we do? For each value of y equal to gxi, we add up all probabilities of p of x equal to xxi, where gxi equal to yj. That gives p of y equals to yj. And for continuous random variables or monotonic functions, if x is continuous with PDF of fx, and y equal to gx is monotonic, that is, it's strictly increasing or decreasing, in that case f of y is said to be f of x, that is a PDF of x of g inverse of y into differentiation of derivative of g inverse of y. So this is a change of variable method. So we can invert the function y equal to gx. That means x equal to g inverse of y. So this ये expression आया कहाँ से? We are learning that कि f of y equal to f of x g inverse of y. What does g inverse of y mean? F of x only. Okay, because y equal to gx. So x equal to g inverse of y. And plug into the formula above to find the PDF of y. I hope I'm clear. In case of any doubts, let me know in the comment section or reach out to me directly. I'd be happy to solve your doubts. Next up, we have 2D transformations. Now we deal with two variables and we define u equal to g1 of xy and v equal to g2 of xy, where g1 and g2 are two separate functions. Okay. To find the joint distribution, we use the Jacobian method. Now, Jacobian is something which we learnt in our first year, okay, while dealing with partial derivatives. So, what happens in Jacobian? For while finding the Jacobian of variables 1 and 2 with respect to variables 3 and 4, we differentiate the variables 1 and 2 continuously, once with respect to 3 and once with respect to 4 variable. Okay. So that way we find the determinant of this particular values. And then we can plug into this formula, that is f of uv equals to f of xy into Jacobian of j. I mean Jacobian of the value. Now basically 1D and 2D transformation इन दोनों में ज़्यादा फर्क नहीं है, because if you see in that one there is f of y equals to f of x into dx dy, okay, and here we have this. So basically this topic is a small one and you just need to remember the formula. This is, you know, expected to be asked in 2 marks. So for the sake of your easy understanding, I've even given here two graphs. So here आप देख सकते हो कि x can take a variety of values in this side, and when y is declared as x squared, the graph of y is like this. And here u and v equals to x plus y comma x minus y. So u and v are shown in two separate axes, but due to two-dimensional, we can't represent them in this graph. So these are the 2D and 1D transformation graphs. Okay. Up next, we have a practice sheet problem where I have solved कि x की आपकी CDF and all दी हुई है. Here you have to find y equal to a plus bx. इसका distribution क्या होगा? So basically here are four sums, but for now I'm just showing number a because b, c and d are similar to a. So y equal to a plus bx, where a and b belong to real numbers. This is a linear transformation, okay? The relationship between CDFs and PDF is standard. Now what is the CDF? Fy of y equals to p of capital Y less than equal to small y. This definition we did in first unit. And what do we know from question? Y equals to a of a plus bx. So we simply plug in this value of y. So a plus bx is less than equal to y. अब हमें क्या करना है, अब हमें इस पूरे एक्सप्रेशन को बस x को हमें लेफ्ट साइड में रखना और बाकी सबको राइट साइड में ले जाना है. So what do we do? We simply derive both of these expressions, okay? That is, x is less than equal to y minus a, then x is less than equal to y minus a by b. If b is greater than 0, then this, or if b is less than 0, then 1 minus ho jayega. Why? Because b is in the denominator. So we need to keep the overall thing positive, that is between 0 and 1. What is the PDF? PDF is fy of y equals to 1 by because 1 by mod of b fx y minus a by b. That is what do we do here? We did that dx by dy thing. Okay, so here we simply took the determinant of the b variable because it's in the denominator. Up next we have number b, where also we find the CDF in a similar fashion, and then the PDF y equal to tan x. Now look, this is not a linear transformation. Okay, तो non-linear transformation में दिक्कत क्या आती है? We have to deal very carefully with the range and domain everything. So invert the function. X क्या हो जाएगा फिर tan inverse of y. अब trigonometric identities के मुताबिक x will lay between minus 90 degree to plus 90 degree, so that tan x is monotonic. Okay, and monotonic का मतलब क्या है? Strictly increasing or strictly decreasing. So अब CDF क्या हो जाएगा? CDF will become f of y is equal to p of y less than capital Y, that sorry small y, and then p of capital X is less than equal to tan inverse of y. So f of x of tan inverse of y. PDF क्या हो जाएगा? ऊपर वाले का differentiation हो जाएगा and we'll get this particular value. So this is the required distribution. Now y equal to cos of x. Now this is a non-monotonic function, okay? Because cos function is not a one-to-one in general, so the transformation splits into branches. इसमें काफी सारी वो होंगी, जैसे we can find out this particular part, and then PDF will be this, that is fx of cos inverse y divided by 1 minus y square under square roots. So abhi I have attached another sum which you can just practice for and then verify the solution from the attached drive link. Hopefully I'm clear. Please let me know in the chat section. Okay. Next, moving on to the next part, that is mathematical expectation and variance. So what do you mean by expected value? The expected value of a random variable is essentially the average outcome we would expect if we repeat an experiment many times. So what is the formula for a discrete random variable? For a discrete random variable, the expected value is given by E of x equals to sigma or summation of x with the product, that is we multiply probability of x equal to small x. And then for a continuous random variable, we simply integrate the overall value, okay? Where x is a value that the random variable can take. Probability of x is the probability of x taking the value small x, and f of x equal to PDF of continuous distribution. So while explaining unit 1, I had already given this dice wala example, okay? So that E of x equal to 1 by 6 into summation of 1 to 6. Now 3.5, that is the expectation का ये मतलब नहीं है कि आप dice roll करने से आपको 3.5 मिलेगा. That is a practically impossible thing because हमारे dice में या 3 मिलेगा या 4 मिलेगा. There's no in between like 3.5. सो इसका मतलब ये नहीं कि आपको 3.5 मिलेगा. एक्सपेक्टेशन का ये मतलब है कि आप जितनी बार डाइस को रोल करोगे एक्सपेक्टेडली द एवरेज वुड बी अराउंड 3.5. नाउ इसका एग्जांपल थोड़ी देर बाद आपको मिलेगा जब हम लोग CLT डिस्कस करेंगे, दैट इज सेंट्रल लिमिट थ्योरम. Now what is the variance? Variance means how spread out the values of a random variable are around the expected value. For larger values of variance, the values are more spread out. So variance of x denoted as var of x is where x equal to expectation of x square minus expectation of x whole square. Okay, so this is a bit tricky part because these two are two different terms. Okay, वन एक में आपको expectation of x square निकालना है, दूसरे में expectation of x whole square निकालना है. So kindly be careful with this. Okay, so let us use the same dice roll example. So पहले हम e of x square निकाल लेंगे. So after computing with the given formula, we get 15.17. And variance क्या होगा? E of x square minus E of x whole square. So expectation of x we got as 3.5. So we subtract the square of 3.5 from 15.17 and we get 2.92. So the variance of the dice roll is 2.92, meaning the results tend to spread out about 2.92 units away from the expected value of 3.5. Okay, so if you draw it graphically, it will be more clear to you. So standard deviation is nothing but the square root of variance. Okay, it is the like variance is said to be the square of standard deviation. So for the dice example, we had variance is 2.92. So if we take the square root, we'll get standard deviation of x equal to square root over 2.92, that is 1.71. This tells us what? That on an average, the outcomes are about 1.71 units away from the expected value of 3.5. Up next, we have linearity of expectation. Now, what does linearity mean? One of the most useful properties of expectation is its linearity. This means that two or more random variables x and y के लिए if we have such an expression e of ax plus b, that means we can break it down into e of ax plus e of b. अब expectation of the product of a constant and a random variable is the constant comes outside the bracket, so it is a of, that is a multiplied by expectation of x plus b. सो ये ऐसी प्रॉपर्टी नहीं है कि ओनली इफ एक्स एंड वाई आर इंडिपेंडेंट. दिस प्रॉपर्टी होल्ड्स इवन इफ एक्स एंड वाई आर नॉट इंडिपेंडेंट. नाउ this question came in MST2 as well. It was the sixth question if I'm not wrong. That is, आपको x की expectation दी गई थी, that is x की values, and you had to find out certain number of expectations. So please remember this particular formula. It would really make your other sums very easy. Okay, now we have variance of linear combinations. Now linearity is just there for expectation. Okay, now var of ax plus by does not mean a of var x plus b of var y. No, that is only valid till expectation. वेरिएंस में आपको दो इंपॉर्टेंट फॉर्मूलाज बता देता हूँ. Variance of ax, where a is a constant and x is a random variable, is a square variance of x. Okay, not a variance of x, it's a square variance of x. And variance of a constant, that is, imagine variance of c, is equal to 0. Okay, so if x and y are independent, then covariance of x and y is also 0. This is another important property. Now, what is the variance of a linear combination? It is a square var x plus b square var y plus 2ab into covariance of x and y. So either आपको covariance question में दिया रहेगा या आपको निकालना पड़ेगा using a formula. So covariance की formula was there in unit 1. So in case it's not there with you yet, I request you to revisit the unit 1 first. Okay. Up next, we have what is conditional expectation. So conditional probability was something we discussed in the previous unit. So conditional expectation is something similar to it. Fine. In conditional expectation, E of y by x represents the expected value of y given that x has a specified value. So for discrete random variables, we summate the probability into the variable over the same variable, and for continuous random variables, we integrate the conditional probability multiplied by the variable from minus infinity to plus infinity. So for conditional expectation, I urge you to, note down the formulae because this is a bit different than conditional probability. Fine. So we have a practice problem where we have expected value of a dice roll, the variance, the standard deviation, everything. So this was the problem which was also there in your MST2 question number 6. So if you can compute expectation of x from this given table, you can easily compute expectation of 2x plus 3 as well. That is 2 into expectation of x plus expectation of 3. Expectation of 3 is 3. Okay, expectation of a constant is always a constant. Variance of a constant is 0. You have to remember that thing. Okay, so here I have step by step solved the entire sum, so you can just check it out. Okay, after that I have attached a few more problem sums which you can practice here. Okay, like expectation is a very common topic from unit 2. In MST2 almost 6 out of 7 questions were from this topic only. So I'd request you to go through all the sums because this is supposed to make an important part of your paper. Okay, now we'll move on to the next part of the second unit, that is MGF and moments. Now imagine you're given just one compact mathematical expression and from it you can extract everything you want to know about the distribution, its mean, variance, higher order moments, everything. So how can you do it? That can be done using a MGF, that is moment generating function. So this equation, okay, mxt equal to expectation of e to the power tx, where what is small e? Small e refers to the natural logarithm. Now, this simple looking function literally holds the entire DNA of a distribution. Just like how one strand of DNA can tell you everything about a person. So ये एक इंटरेस्टिंग एनालॉजी है, ओके, वेयर बाय जैसे एक आदमी का डीएनए से हमें उसके बारे में सब कुछ पता चल जाता है, सिमिलरली एमजीएफ से हमें एक पर्टिकुलर फंक्शन के बारे में सब कुछ पता चल जाता है. We can literally compute its mean, variance and every single thing related to it. Now as such a पढ़ने का टाइम होता है तब we feel like MGF is such a tedious topic. Computing it is so difficult, but its mathematical use and beauty is really a very important and significant one. Okay, so remember this DNA thing. If MGF ka definition comes, at least you can write that. Ki what is MGF? It tells us everything, the mean, variance, higher order moments about a distribution. Why is MGF so important? It generates moments, that is mean, variance, skewness, etc. It's a tool to show convergence in distribution that is used in proving CLT. CLT is our next topic. So while proving CLT, we'll be using this program. Okay. So then, yeah, it helps us to work with sums of independent random variables, and it's easier to handle in theoretical proofs than working with raw probability functions. Now, what do you mean by moments? Moments from MGF, the secret extraction tool. So first derivative of the moment generating function, that is MGF, gives us the mean. आपने अगर MXT निकाल लिया हो and you take a first derivative of this, then you will get the first moment or the mean. Second derivative gives us the second moment, that is E of x square. Okay, that is, if this is a capital A, then d2a by dx square will give us the second moment. Mind you guys, second moment is not variance. Second moment is not variance. Second moment is e of x square. Okay. Variance is e of x square minus the first moment ka whole square. So m double x of 0 minus m single x of 0 whole square. That is the moment. Next is MGF of sample mean and CLT. So MGF of sample mean is given by this formula, that is mx bar of t. So आप इसको अगर e to the power tx लेके वो करो, then you'll get this thing कि m of x t by n whole to the power n. So next practice question is find the MGF of normal distribution and hence find the first two moments. Now this was a question of your MST2 which most of us the students could not complete it. Okay, so what is to be done in such a question? So firstly, let's declare the program key. How is the MGF of normal distribution defined? It is defined as m of xt equals to expectation of e to the power tx, and since this is a continuous function, so we integrate from minus infinity to infinity e to the power tx into fx of x, where the PDF is defined by this particular expectation. Okay, this particular expression. So after integrating and putting up all the subsequent limits, we get this particular answer, that is mx of t equal to e to the power mu into t plus half into sigma square t square. So expectation like exp means exponent or e to the power. Okay, सो आपको एक चीज याद रखनी है कि अगर आपसे पूरा ये लाइक इंटीग्रेशन या समेशन जो भी है, इवन इन केस यू कांट कंप्लीट इट, यू नीड टू शो द फाइनल आंसर एटलीस्ट. ओके, so step markings will be there, but please try to at least derive the final expression. So a few of them you try to remember. Okay, so what are the first and second moments about origin? Our answer does not end here, it is just the MGF. So first moment is differentiate with respect to this. So upon doing the calculations, we get its mu. And what is the second moment? We differentiate once again. And what do we get? Mu square plus sigma square. So these are the first two moments, that is mu and sigma square plus mu square. Up next, we have theorems relating to sample analysis. First is Chebyshev's inequality and law of large numbers. So what is Chebyshev's inequality? Chebyshev's inequality states that for a random variable x with mean mu and standard deviation sigma, probability of, now this is one important equation which you have to remember, p of x minus mu when it's greater than k sigma. Okay, k sigma is a particular expectation expression. When the probability of x minus mu is greater than k sigma, then it is less than equal to 1 by k square. Okay, so this expression is known as Chebyshev's inequality, and it's used to solve many different problems. So I have here I have shown a graph that helps you to visualize the normal distribution. Okay, so for example, at least 75% values lie within the 2 sigma of the mean and 89% values lie in the 3 sigma of the mean. So why is Chebyshev's inequality useful? It provides a guaranteed bound even when the exact distribution is unknown. So आपको अगर कोई distribution दिया रहे जिसकी आपको like bounds पता ना हो, तो Chebyshev's inequality helps you to evaluate the bounds. And it applies to any distribution with a finite variance. Okay, in variance should not be infinite. Now why should it not be infinite? That we'll study in the law of large numbers. So what is weak law of large numbers? Weak law of large numbers. So let x1 to xn be independent and identically distributed random variables with mean mu. So what is this IID? Now imagine you are comparing the marks of 10 students from a class. ना अगर आप सारे ब्राइट स्टूडेंट्स या लाइक गुड मार्क्स स्कोरिंग स्टूडेंट्स को लेते हो, देन ऑब्वियसली सबका मीन भी ज्यादा होगा। एंड आप अगर कुछ लाइक जिन्होंने एवरेज या लो मार्क्स स्कोर किए उनके मार्क्स का एवरेज या वेरिएंस निकालो, वो कम आएगा कंपेयर टू द फर्स्ट ग्रुप। सो व्हाट डू वी डू टू एंश्योर फेयरनेस? ओके, हम क्या करना चाहिए कि एवरेज एक्चुअली एवरेज या एवरेज से ज्यादा या कम ना हो। For that, we need to take IID, that is independently and identically distributed random variables. So we define the sample mean as xn ka bar equals to 1 by n, sigma of I equals to 1 to n x of I. This means जब जैसे जैसे x of n, that is sample mean will converge to population mean, तब n is tends to infinity. That means जैसे जैसे number of sample increases, n जैसे जैसे बढ़ता जाएगा, वैसे वैसे the sample mean will converge to the population mean. Okay. So basically आप ये देखो, ठीक है, कि जब n इक्वल टू 0 से 10 तक था, तब कहाँ सैंपल मीन था और कहाँ पॉपुलेशन मीन था। ओके, दिस रेड लाइन शोज द पॉपुलेशन मीन। बट जैसे जैसे नंबर ऑफ रोल्स ऑफ अ डाई बढ़ते गए, okay, the number of times we kept rolling the die, the sample mean what happened, it almost became parallel to the population mean. Firstly देखो आप इतना difference है दोनों में, but जैसे जैसे हम n की वैल्यू बढ़ाते गए, it kept converging with the population mean. Okay, so please remember this particular statement, that for weak law of large number states that as the number of samples increases, the sample mean converges to the population mean in probability. Next, we have what is the central limit theorem, or CLT. Let x1, x2, xn be independently and identically distributed random variables with mean mu and variance sigma square. Then the standardized sum z equals to xn minus mu, that is sample mean minus population mean, whole by sigma by root n, where sigma is the standard deviation and n is the number of samples. So what is the CLT? When x1 to xn are IID random variables with mean mu and variance sigma square, then the standardized sum converges in distribution to the normal distribution as n tends to infinity. So basically it's a continuation of WLLN, you may say. उसमें क्या था, उसमें था सैंपल मीन कन्वर्जेस टू पॉपुलेशन मीन एज n टेंड्स टू इंफिनिटी। इधर क्या है, दिस इज द सम converges to the standard deviation. Now I am showing you, even if the original variable is not normally distributed, the distribution of the sample mean becomes normal as the size grows. अब ये देखो, ये एक sum of 30 dice rolls है, okay. The rectangle bars, they show you क्या, they show you the original variable का distribution. So basically it's not normal distribution, but when the sample mean का distribution हम लेते हैं, at that time we see the blue line is literally normally distributed. Okay, so this is the CLT. So इसका central limit देखो, central limit is somewhere between the higher limit and lower limit. That's why this theorem is known as central limit theorem. Okay, इसमें क्या है, even if the original variable is not normally distributed, distribution of the sample mean becomes approximately normal. Now, why is it powerful? It allows us to use normal distribution for many problems. Now, काफी problems में ऐसा होता है कि उनकी distribution normal नहीं होती, तो हम क्या करते हैं उनकी if we take the sample mean, we can get another normal distribution. And it explains why we see normal shaped curves in real data. Why? Because of this CLT use करके हम अगर original variable का normal distribution ना भी मिले, we can we can distribute the sample mean, which becomes approximately normal. Even if you don't understand, at least see this graph, okay, कि जो main हमने variables लिए थे, those are not normally distributed. कोई ऊपर है कोई नीचे है, फिर कोई ऊपर है फिर कोई नीचे है, फिर कोई ऊपर है फिर कोई नीचे है. So that is a total chaos out there. But जब हमने उनके sample mean का curve draw किया, that is what that looks like a normal distribution. So this is CLT, or central limit theorem. So then I have a few practice sheet problems. So here firstly we can use Chebyshev's inequality. So Chebyshev's inequality का कोई भी sum हो, what do we do? For sums related to Chebyshev's inequality, simply आपको main वाला formula लिखना है. Then you have to compare the given values with the main formula. Okay, and then you have to come to certain conclusions. And उसके बाद you have to put the necessary values. Okay. Step 2 is compute the sum and variance. So expected value of x we find out and variance also we find out. And finally we apply Chebyshev's inequality because what? Because now we have the variance as well as the mean and stand expected value. Then we calculate the actual probability. Okay, because what was the question? The actual question was compare this probability, okay, this probability with the actual probability. So this probability is 35 by 34 and actual probability is 1 by 3. So basically Chebyshev's is literally double of the actual value. Okay, then we have another practice sheet problem based on CLT, that is Central Limit Theorem. So firstly आपको CLT का वो लिखना है the statement. Then for Poisson distribution you need to note down the mean and variance. Then the sum will have mean what, variance what and standard deviation what. Then for CLT आपको standardization करना है जो law of large numbers या Chebyshev's में नहीं था. CLT में आपको standardize करना है, that is you want to find out Z. नाउ z निकालने के बाद क्या है, आपको एक z टेबल एग्जिस्ट करता है सिमिलर टू लॉग टेबल्स. ओके, बट लॉग टेबल्स में क्या, लॉग टेबल्स में like z tables it's easy to find out certain values, but z table one is a bit confusing and tricky because you've never used it before. So as of our upcoming examination it is expected कि ऐसा कोई like CLT का sum आए, then the z values will be provided to us in the question paper. So similarly you can just plug in the values and compute the final result. Okay, so this is the estimated probability using the CLT or central limit theorem. Now, so it's easier for you to understand. I've even attached a graph. कि देखो the sample mean is looking like a normal distribution. Okay. Below I have attached a few more sums for practice as well. So with this we move on to the last topic, that is advanced joint distributions and conditional expectations. So इधर मैंने सबके definitions I have attached. Okay, कि joint distribution क्या है, we studied it in the previous unit. Conditional expectation, independence and marginalization. So here I have attached two graphs for you as well. Joint distribution and marginal distributions दिए हैं. Then what is conditional probability or expectation? So probability conditional I have already explained in the previous class, and here's the conditional expectation, where for discrete variables we summate these values and for continuous variables we integrate the values. And independence means what? Probability of x and y is equal to probability of x into probability of y. So with this we come to the end of unit 2. So here I have attached a formula sheet. So what did we do? First we did transformation of random variables. Then we did MGF, Chebyshev's inequality, law of large numbers, central limit theorem, joint distributions, and the various probability. Then discrete and continuous distributions, PDF, PMF, and MGF table. So here I've also attached a table for your enhanced revision purposes. Okay. So with this, I'd conclude my today's video. Hope it's clear to you all the unit 2, and next day we'll complete unit 3, that is sampling and estimators. Thank you so much. In case of any doubts, kindly let me know in the comment section or feel free to reach out to me. So that's all about unit 1 and unit 2. Thank you.